add signals. A signal x of t or x of n is referred to as an even signal if x of minus t equal to x of t. Here x of minus n equal to x of n. This negative will not come here. This negative here positive. If we get negative here positive only. Here also this negative will not come here. Positive only. Then it is called a even signal. A signal x of t or x of n is referred to as an odd signal if x of minus t equal to minus x of t. That is, this minus will come here, other side, equal side, after equal, then it is called a odd signal. If negative also in this discrete, if it is coming here, then it is called odd signal. It means, what is the difference between here for even and add? If negative not come back after equal, then it is called even signal. If negative will come, positive is nothing matter here. Anyway, if negative will come after equal, then it is called odd signal. Examples of even and odd signals are shown here. Examples of even signals A and B, odd signals C and D. C and D, odd signals. A and B are even signals. This is A, this is B, even signals both. Here, this is the x of t in y-axis. Here in x-axis tan. Here is the 0. Here, this is the negative side. This is the positive side. Here, coming like this. Then positive also mirror image of this negative side. So what here coming in negative side, it is same here coming mirror image, then it is called even image. Like this same. Here also same. Minus 3 to 1. Minus 4, 3 to 1. Same here. This one coming here. This one coming here. Minus 3, here 3. Minus 2, plus 2. Plus 1, minus 1, plus 1. So, in this discrete, this is, in this discrete signal, this is the even. Here, n, number of samples. That's why here n, x of n. Here also like that. This one coming here, same. This slope here, this one here, this one here. So here coming. Here start end, this end here started, this start here end. Start, sorry, stop, start, stop, like this you can say for understanding purpose. Here in odd signals, time t, x of t, this is x-axis, time t, y-axis x of t. Okay, here this is a 0. Okay, here in negative side they are going sorry. Here this is negative side, here 0. It means this is positive side going like this. It means this is negative, here positive. Here also This is negative, this is positive. This one, this is sent here. This one, here negative value, here positive. Here negative, here positive. Okay, this end coming here. So this is the odd signal. Here, actually, if it is here, this side, this one coming here, this one coming here, this one coming here, this minus one coming plus one. This is n number of samples, x of n discrete signals. It means here this negative, here positive, this negative, here positive, here plus, plus plus, minus minus, minus minus, no, sorry, this is plus, no, plus minus, here this is minus, this is minus, minus, here minus, this is plus. Okay, here this negative side, what is here, that same here in mirror image, same like in this continuous signal, in discrete signal also same like this, but here not will same negative image, not mirror image, here also same. That's why here odd signals. Any signals x of t or x of n can be expressed as a sum of two signals, one of which is even and one of which is odd. That is, x of t equal to x of e of t plus x o of t. It means even. This is the even signal, and one is the odd signal. It is called x of t. Like this in discrete also, x of n equal to xe of n plus xo of n. That's same. Even signal, odd signal. Two signals sum. Two signals sum. Sum of two signals. One is even, other one is odd. Here in continuous, and even the discrete also, one is even signal, another one is odd signal. Where xe of t equal to, that is uh, xe of t, that is this one, xe of equal to 1 by 2 of x of t plus x minus of t. That is here even signal of it means half of this total of, it means x of t plus x of minus t. See here, yeah, we can say this one x of here, yeah, x of t, t. Okay, so It's considered as x. Okay. Here x of t, x of t, x of minus t. This is x of minus t. That is xe of t. This is the xe of t. This is total. Here half, this is half. That's why this is half only, no? That's all. Then this one half. Okay. Like that same. In discrete also same like xe of n equal to 1 by 2 into x of n plus x of minus n. That is open bracket. That is, this is even part of x of t. This is even part of x of n. X dot of t equal to, that is odd part of t. X of t means this is odd part, total odd part. X of x o of t means odd part of x. X o of t equal to 1 by 2 xt minus, here is the button, x minus x of minus t. So this is the odd part. Here x naught of n equal to 1 by 2 x of n minus x of n minus 1. Here minus is there in odd, in odd. In even, here adding also, what is this? Even. Here same. What is coming here in odd, even also came. Here what is coming in odd, in discrete signals, same coming in discrete even part. So note that the product of two even signals, or two odd signals is an even signal, and that the product of an even signal and odd signal is odd signal. Part 1.7. Note that the product of two even signals or two odd signals is an even signal. Multiplication of two even signals or odd signals is an even signal, and that product of even signal and an odd signal is odd signal. Plus plus or minus minus, even here. Plus into minus or minus into plus, odd signal. It means one even signal multiply with the another one odd signal equal to one odd signal. Periodic and non-periodic signals. A continuous time signal x of t is said to be a periodic with period t if there is a positive non-zero value of t for which x of t plus t, small t plus caps t equal to x of t all t, for all t. That is, here for periodic and non-periodic, a continuous time signal x of t, continuous time signal x of t is said to be periodic with period t if there is a positive non-zero value. Positive non-zero value, that is here no zero value, only positive value of t, for which x of t, the t for continuous time signal, t for continuous time, this caps t for periodic. So continuous time